The only thing in life that's better than one Gen 4 SSD is 2. Even better than that, 3 Gen 4 SSDs in RAID. Yes, I know this isn't 2002 when everyone still used hard drives in RAID 0. All the experts, in fact, tell you it's just not worth it with today's fast Gen 4 M.2 SSDs. What those experts don't tell you is sometimes you just have to have the need to show off to your friend who only has one Gen 4 drive. Yes, they got 1 gig internet, I got 10 gig internet. They got a 3080, I got a 3090. Yeah, I'm that guy.
This video is sponsored by SK Hynix, the maker of fastest-in-class SSDs. The new Platinum P41 PCIe Gen 4 NVMe SSD exhibits technical excellence driven by unmatched speeds and reliability. The Platinum series represents the company's flagship retail lineup geared towards gamers and content creators looking to turbo boost PC performance. Check out the link in the description in order to grab the Platinum P41 today and give your PC a huge upgrade.
More than a decade ago, PC enthusiasts commonly ran 10,000 RPM hard drives in RAID 0 for that extra nitrous boost of performance for their PCs. Modern day SSDs, however, have made such configurations obsolete with a single M.2 drive capable of hitting 7 GB in read speed and 6.5 GB in write speed. Basically, so much speed and so little latency, the conventional wisdom today is just skip RAID entirely. But wait, if RAID is such a waste, why do all performance-oriented motherboards offer it? Are they just marketing cynics exploiting our need to have something better? Or do they know some of us still want to have the absolute fastest thing there is, even if we won't ever use it? It would have been like asking George Mallory not to climb Everest because the view was just fine down here. So to celebrate the spirit of old school enthusiasts, I decided to sit down and make a 3 Gen 4 RAID array worthy of bragging to my fellow nerds about. Well, to specifically brag to my coworker who only has 1 Gen 4 drive. My platform of choice is the most modern one available, Intel's Core i9-12900K on an Asus ROG Maximus Z690 Hero. The board features 3 PCIe expansion slots and 3 onboard M.2 slots. For those who need more, Asus also includes a Hyper M.2 PCIe adding card with slots for 2 additional M.2 drives that can be run in RAID. See, Asus wouldn't include the Hyper card if you didn't crave RAID, right? If you're wondering why not just populate the 3 onboard M.2 slots and call it a day, it's not that simple. In fact, nothing is simple with configuring an SSD RAID on an Intel Z690 board. Performance with the 3 onboard M.2 slots was simply unimpressive when I tested it. And because of how PCIe is divvied up on the Z690, it was difficult to achieve performance and even get the M.2 drives to appear sometimes. It was like a game of whack-a-mole where I found myself having to build and rebuild the RAID array more than 24 times as I moved drives and the Hyper M.2 card around the system just to find the best combination. Even more perplexing, I found performance on Z690 actually got worse trying to add a 4th M.2 drive to the mix. So 3 it is. For those used to installing Windows from a USB key with nothing else needed, installing RAID isn't as simple. First, you'll have to stumble yourself into the correct M.2 slots to use. It's different for every motherboard. And then you'll have to enable volume management features in the BIOS as well as create the RAID array. For this RAID 0 project, I use a 128 kilobyte stripe size, which storage experts say is an irresponsible size since most files you access are far smaller. To them, I say I've already ignored you about creating a RAID array already, why start listening now? During install, I also had to separately download drivers from the motherboard maker and manually point the installer to the drivers. just like F6 floppy disk drivers in 2002 on hard disk RAID builds. In the end though, I ended up with a massive 5.7 terabyte RAID 0 array that is indeed brag-worthy. Here's a hint: you can backwards brag about how fast your RAID is by telling friends how hard it is to set up a Gen 4 drive array and how it took you all weekend long just to get it right. How fast? A single P41 drive can hit about 7 gig reads and 6.6 gig writes. My 3-drive RAID array could reach sequential 21 gig reads and 18.7 gig writes with a frankly silly queue depth of 32 in Crystal Disk Mark 8. At this point, my negative nerd friends will just sputter, "What do you need 21 gig read speeds for anyway?" The argument, they say, it's just overkill. They'll also cite such benchmarks as 3D Mark storage tests that shows the performance difference for gamers is minimal. But I was prepared for that argument using the also real-world Aja test, which tells me a single P41 gives me just under 6 gig read and writes. My RAID array will hit 14 gig read and writes using Sony 5K 16-bit RAW codecs. And no, I don't have a video camera that shoots at 5K, and I have no plans to buy one. But sometimes you don't do things because it's practical. You do it to show off.